Okay. So, hello everyone. Thanks for joining the session. And as I discussed in the last session regarding the problem statement for the heart disease classification using Python. So 99% of this code can be written in Python, just in case in 1 or 2% where if you want to use this OpenCV uh, for the visualizations, and you can use it just in case. Other than that, most of the tasks can be done within Python itself. So I think the problem statement has already been shared in the last class, the PDF also. So the task what was given was we have the data set, and the data set contains the information. So here what we have is the age, and let me expand them. So we got the age column and the gender, and we got a CP, the rest BPS, trust BPS, and cholesterol, CHOL for cholesterol, FBS, and I'll talk about this in detail also. So the column A to N, we do have the target. So within the problem statement, there was one question also regarding saying that we need to add one more column, that to be like a calculated column, and then uh, complete the other tasks. So the task, for example, one of the tasks was like we got a gender column. So make sure that you got, if it is a 1, make it as treated as male, and if it is 0 for female, the same case. Okay, with the cholesterol levels, if it is high or low, and also with the thalash levels, is a high or low. So there was a criteria. So when we look for the data, so we got a nearly 303 individual columns. So out of age, so as I said, first is the age, the second is the gender, the third is the chest pain type. Yeah, this was one of the primary thing which I was talking about. So gender, if it is male and female, and the chest pain types, we got 4 values. So if we look for the chest pain types, they are like minor or very minor, or like a moderate or serious or very serious. So based on the values, we just need to convert them. And also we got resting blood pressure, like an BP levels, and then the cholesterol and the fasting blood sugar levels, and then the resting electrocardiographic results. So like in uh, ECG, right? So you might have heard of ECG. Then the maximum heart rate, whether it's high or low. Then the enigma. So we still have few more columns like old peak. So it's like uh, ST depressions, like an induced by, so this is like an exercise related ones. Okay, and then we got again on the slope of the peak exercise, the values, and also the number of vessels, like in the blood vessels. And there is one thing called thalash, which is again which I've notified, like in what is thalash over here in the problem statement. So thalash is nothing but the maximum heart rate achieved. So that is one of the thing. So when we get into deeper regarding the problem statement, so out of the columns, 13 columns, so we have the first task is like preparing the tools. Like if you have the tools, that's well and good. And if you don't have the tools, then try to install it. So let me jump into the code straight away. So here is the problem statement, which I've shared in the PDF format, the same thing. So I'm going to share this again also today. So let's get into the solution thing. So here, what I've used is, so here I usually call the title like Python project heart disease prediction. So import warnings, warnings dot filter warnings, so ignore. So here, the advantage of using these warnings, in the sense, whenever there are certain warnings, you won't be having those warnings displayed in the code. It will be hidden. So to avoid the warnings, so what you have done is to uh, hide the warnings or something like that, whatever it says, import warnings, and warnings dot filter warnings equals to ignore. So this will avoid the warnings under the code. Okay, whenever there is a code, and when you try to apply this, like an import warnings and warnings dot filter warnings ignore. So it's not mandatory, but this is a good practice to use, like an import warnings and warnings dot filter warnings. Okay. So the next step is like an here load the data set and display first 15 records. So here what I'm trying to do is when you try to load the data set, the very first thing is we try to use pandas. Okay. As you already know the pandas, it's used for the file operations, right? So what I've done is df equals to pd.read csv. So I'm reading the CSV file. The file name for the CSV is hard.csv, right? So I need to read the CSV file, right? So when I want to read the CSV, the first step I use df equals to pd.read underscore CSV. So this is a step which is helping me to read the files. Then the next step is df dot head. So this one is a next step. What I'm going to do here is, so I want to load the data and display the first 5 rows, right? So this is what I'm trying to do. So when I want to load the data, so here I'm giving as header equals to 10. The rather I will go with 5. Okay. So this one, when I run it, so I get the information like in first 5 records, starting with 0 and 4. Okay, 5 records. So I'm trying to read the CSV files and displaying the head. When I say head of n equals to 5 will be the first 5 records. So this is one of the steps. And the next thing is give the statistic summary of the data set. So when I say the statistic summary of the data set, it's more or less. So here, like a count, mean, these are all the statistics, like and what statistical functions, like and mean, standard deviation, uh, these are all comes into the picture. So before this, I just give one thing like an to show an image. I got a simple image just to show to the person or something like that. Anyone who wants to show that, okay, how the heart looks like within the code, right? Because we're talking about the heart disease, right? So generally they get an idea like and how the heart looks like and how the image being provided. Okay. So here I got the JPG file. So here, whatever the file I have in my directory, hot.jpg. So what I'm trying to do is I'm reading the file and then displaying it. So for this, I've used import CV2. This is nothing but again uh, OpenCV function. Okay, when I use this import CV2, okay, for example, if I put in over here import CV2, so what does it do? See, OpenCV. So OpenCV is generally used for these categories, right? So so you need to have this thing on your machine. Uh, so if you don't have this software or like an module, so you just need to use the pip install OpenCV Python module, install that, and it will be like same as the command prompt. Within the command prompt, you just go to the CMD function and then say that, okay, pip install, pip install open cv iphone python. Okay, so I already have it, but this is what you're trying to do. So if you want to install the OpenCV on a machine, just type in this command pip install OpenCV Python. So this will install the required libraries. And once it is done, so you just come back and utilize it, okay, in the code. So import OpenCV means, so it will import the library and then a module. Then the thing is that matplotlib, you already know that, okay, to get the graphics and everything. So visualizations, use the matplotlib. So here, if you want to get to know about more about this OpenCV, so you have this thing. I'm going to add this over here also within the code. So, okay. So as a comment, okay, to learn more about OpenCV. So here you will have all the details like what is the purpose of OpenCV and where else you can use the OpenCV and everything. So uh, this you can go through it once you have more time. So let's get back to the code. So here I've used the import CV2 to get the image displayed, and also the import matplotlib as well. So that too we are trying to create like in 0 to 400, 400, 300, and also we are trying to give the plotting like in sizing 500 by 500 sizing. Okay, so this code will help uh, to get the graph displayed in a proper way. So this is not mandatory in the project, but to uh, give a very good impression to the employer, saying that okay, this is what the heart looks like, and they will be impressed. So the task is, the next thing is give a statistical summary. So when you say df dot describe, so it will pick up all the values, right? Like a count, mean, standard deviation, minimum, maximum, everything. It will be picked up for all the columns. So this is the statistical functions. Like when you said df underscore describe. So this has been done. Then next we have something called null values and printing the names and also unique values. So let's see what we're trying to do. So print the data types. So if you want to know the data types of the all the fields, so here what we are trying to do is print df.shape. So this will help to find out what are the different columns and what are the different types, data types. So out of which only thing is old peak is like a float 64. And if I go to this Excel sheet, old peak 2.3, 3.5, these are all like an float values. We got a decimal values in it, right? So that's what we have. The next task is to find the null values in the data set. So uh, as you already know, when you say the null values, when I say zeros and all, so how many zeros are there? So if zero is a null value. So in almost in each and every column, there are null values. If I run it, right? So why does data types convert to int 8 when used? Okay, just a minute. Convert to int 8 when used is convert to category type. So where is that in the sense? Here it says like int 64. Convert to int category type. Okay, let me tell you. So here, whatever the fields, whatever we have, they're all integer, right? Integer. So, oh, okay. But in general, okay, why does data types convert to int when used to convert to category type? So here, Shravya, what I mean to say is, so in reality, when you have the data set, you try to categorize properly. Like in, so when you convert them into proper data types, then you are able to achieve the target, right? So for example, genders, if I use like a male and female, okay, uh, it will be in the uh, alphanumeric, right? It will be the string format. So if it is a string format, you may not be able to use it for calculations or something like that. For example, if you got ones and zeros, that will be easy to like in categorize, right? So it's more or less like, first of all, try to see what are the different types of data there. If you think that, okay, if you want to convert to string to numeric, try to achieve the logics. I will show you what I'm going to do in this next sessions. So the next task will be the same thing. So here, what we have done over here is df dot is null. So this function is helping me to find out how many columns are there and what are the columns where the null values are being displayed, right? So next thing, what I'm trying to do is the names of all the columns. Yeah, this is one of the things. So what I'm trying to do is I just need only the headers. Headers in the sense, these headers. I'm interested in only the headers for all the columns. So for that, what I'm trying to do is df.columns will give the headers for all the columns, right? So the next task is find and print the unique values. So unique values in the sense, so whatever the values are there. For example, in gender, you will see only zeros and ones. For example, in gender, you got 1, 1, 1, 1, and zeros. So just in case if you filter the information over here, so I see only 0 and 1. So these are the unique values. So the same case in age also, if I filter the information, right? So what happens is, okay, let me filter from all the columns, and that will be easy. Filter. So in age also, right? So even in the age column, so if it is visible, let me zoom it little bit. Okay. So the age column also. So these are all the unique values. So I don't want to have the repetitions ones. I just want to have the unique values. So these values are there in the age. So I just want to identify the unique values in each and every column. So for that, there is a method. What I've done is I've used the for loop and then trying to uh, get into the list and display them. So here I got all the unique values from the age, gender, CP, and all. So everything has been displayed over here. So that gives the unique values for all the columns. So uh, the stars and everything just to make sure to differentiate them. So it's not mandatory to apply these many things, but uh, I'll give a, I get a clear cut division saying that, okay, these values belongs to age and these values belongs to gender, etc. Okay. Coming to the next step, I think there are a few steps. Okay, here we'll be talking about the conversions. So before getting into the conversions, so let's see what are the things for the plotting. Okay, I want to plot the distributions of all the columns, right? So here I've used Seaborn as well. So Seaborn is again same type like a matplotlib for the graphical representations. So just like matplotlib, if I want to know about more on Seaborn, right? So this is again the statistical data visualization, right? So all the graphical visualizations can be used using Seaborn also. So to get a good quality visualizations, I just use both like in Seaborn and Matplotlib, right? So I've created distill plots. So the same case, what I've done is I've used a for loop in the sense for each and every column, automatically it picks up the plotting. See the age, one for the age, one for the gender, one for the CP. So it gives the clear cut plotting. So for each and every column. So you got 13 means I get all the 13 ones. So to get all the 13 ones, I've used the for loop to pick up automatically each column and display in the display the plots, right? So the same case currently initially I've defined uh, and then what kind of columns to be followed. Okay, df columns, and also show will be to show the values. Okay, so here when I use a for loop, it automatically picks up. So here when I say this dist plots, so it automatically goes to the definition and tries to pick up the column and comes back and displays, right? So it goes iterative process, right? So it's like a loop. So you get all the values automatically. So the next step is what I'm trying to do is plotting, right? So here we have talked about the plot the distributions of all the columns. This is what we have done. And the next step is plot a bar chart showing the comparison between the people suffering from heart disease and people not suffering from heart disease, right? So for this, to differentiate, so the same thing, what I've done is there is a target column. So that is a key column in this one. So the target column over here, it's a very key column. Based on the target column, I am trying to find out, right? So I'm counting the values based on the target column. So the zeros and ones. How many zeros are there? How many ones are there? I'm differentiating them. So the first thing is you got a target. When I click this, I got zeros and ones. So two distinct values. So I'm counting the zeros and ones. So for that, this code will help to create the bar plot. So when I say bar plot, so these are the bar plots, right? So here one more thing is that 0 and 1. So here for this also the heart disease, right? If I show you the code, So there is one thing, condition. So let me say, uh, we are supposed to mention over here. So generally, so 0 and 1s. So here, heart, what I would say is people suffering from heart disease and people not suffering from heart disease. So that's the reason we are separating zeros. Uh, I think I need to, I should have given the values total here, like a nearly about, it's 0 to 120, right? The values. So I'll show you this representation at the bottom, like and how many people are suffering and everything. So the same count. But here, what I'm trying to do is to differentiate them. I've used this code. Okay. So the target columns. So based on the target columns, again, I'm using the gender also, like in how many males are there and how many females are there based on the target columns. So that will talk about in the later examples. So here, the next step is the gender column. Pick the gender column, replace 1 with male and a 0 with female. Okay. So here, I've used this thing, the lambda function, and the lambda function will be used, and also the if then else statement, right? So I'm defining the gender, and the uh, I'm also mentioning that, okay, whether if the value is male, if it is like an, if one, then male. Okay. If X value is equals to 1, then male, else female. So here, if you look at the column, so the gender, I got only 0 and 1. So the 1 is for the male and 0 is for the female. That's what I've been defined. And then I'm trying to plot the suitable visualization. So the males and females suffering from the heart disease. So here, there are two things which needs to be kept in mind. So the gender. So the gender values we are trying to calculate over here. So how many males are there? How many females are there? Right? So plot suitable visualization showing the number of males and females suffering from the heart disease. So here, the reason is all these people over here almost are suffering from heart disease, but we need to uh, separate them. How many are males and how many are females, right? So that is the reason this code will help to visualize the males and females, right? That too, we are creating the bar plot. You can use any other plots if you want. How different is this plot from distill plot? Okay, so here, see, look at the difference. So here we are not having multiple values. For example, in distill plots, so we got multiple variations, right? So you got a age group. So we got an age group category like a 28, 34, 30, 35, 37, and all multiple. So if you want to utilize distill, you can still utilize. The only thing is that here I just want to have these only two variations, like an uh, just I need two bars for males and females. So that's the reason I've utilized this bar plot. So if you say uh, furthermore differences like in distill plots and the bar plots, I can get some more information, distill plots versus bar plots. So let's see. So what do you say within the Seaborn? So what they're trying to say is, I, okay, in this thing, let's pick up some more examples. So here, if you look at this one, so distill plot plots is an univariate distribution of the observations, right? So here again, the bar plots. So again, the whatever you have seen, see the bar chart or the bar graph is a chart or a graph that represents the categorical data with a rectangle bars. So here, the same case, here we got multiple values. So that's the reason we picked up the distill plot. Okay. And coming to this bit, we don't have many values. So we just need to have these males and females. That's the reason we just choose the bar plots, right? So this is the only difference. And also we're trying to see whether the gender column and pick the values. Either it is a male or a female, and then show it up. So what I'm trying to do is putting them into the data frame and then uh, showing it as a bar plot, right? So the next thing is I just want to, so what I've done is I'll show the pie chart in a few minutes. Okay. So other thing is I'm just trying to show the header. Like I just brought the header values or first header values. The reason behind is within the Excel sheet, we got the gender values of zeros and ones. So I've used a code, right, to save the values. If it is a one, save it as a male, and I'm putting it in the data frame, right? So when I place them in the data frame, again, it will be saved automatically. So here, when I try to say df head, so automatically one will be the male, zero will be the female. So the data has been converted. So that's the reason. So this is the code we are replacing here, right? In gender, the columns replace one with a male and zero with female. So this code has been replaced, and the same thing has been shown over here, right? The next step is a CP column. So here, when you look for the chest pain column, like in the CP will be the chest pain, like in 0, 1, 2, 3. For this, we got the conditions like when you say 0 for very minor, 1 for minor, 2 for moderate, and 3 for serious, and 4 for very serious. So the same thing, we are giving the conditions over here. I've used just a simple if then else, right? Simple nested if then else statement has been used. Okay. So here with this condition, and then I'm again trying to put them back into the data frames, right? DF. So the same thing, when you display this, the header, right? I get the CP, like in serious, moderate, minor. So if you want to know how I'm defining as a serious in the sense first three. So it's really the first one is 3, right? CP is 3, right? The first one. So that's the reason the first one is a serious and the second is moderate and minor, etc. So the same thing. So what I'm trying to do is I'm converting the values and displaying in the string format, and then trying to show the header values, right? So the next task is plotting. The plot a pie chart representation, okay, division based on CP. So what I'm trying to do over here is, if you look at these values, so how many um like in how many rows, or like in how much percentage of very minor, and how much percent of the people with a serious, and how much percent of the people with a minor, and how many percent of the people with moderate values. So this has been displayed. So to this you can utilize your own plotting methods. So I just use the pie chart. So either if you want, you can use the bar also. Within the bar chart also, you can still convert them and show it, right, like in the bar. But in this case, you'll get all the layers, like in 47% of very minor, and 7.59 of serious, and 16.50 of minor, and moderate of 28.71. Rather, I prefer pie chart. So this gives the clear information. So someone who is a manager or a director, it will be easy for them to understand uh, the divisions. Like an it's a fair simple, like a donut chart. So here we call as a pie chart over here, right? So pie chart and division based on the CP, like in chest pain, we are converting. So in the same case, to get into the loops, and also I'm using the for loop to get into the loop and find out each and every value, and separating them. Okay. So here I'm separating them in the sense, so already converted them into serious, moderate, minor, already separated them. So that gives the information clearly. It's automatically been displayed. Okay. And also when you say circular, draw the circle, right? So this circle will help to show in the circular format. So this circle will definitely help in the circular format, and also trying to say the giving the coloring also, right? So I may not be able to get into the deeper of all the codes of like and what I'm trying to do over here. But at the end of the day, what I'm trying to say here, here's I'm using the loops to pick up all the rows from column 1, for example, from here. So the header we won't be calculating from the line number 2. to until to the end of this Excel sheet. Okay, so all the rows will be read through, and it will separate, right? Then it will be going. Then it's going to display it, right? So let's get into the next bit of add a column regarding this is like a Talash one, right? So here, as I said, there will be a new column called Tala string, right? So this Tala string will define whether the value is high or low based on the Talash column. So here, for example, so there, if I look at this Excel sheet, there is something called the Talash column. So if the Talash column, if you see like a 150, 187, 172 and all, so if the value of the Talash is greater than 150, then it is high. But how I'm going to define that? So I need to have one more column over here in column O. And if it is 150 or above 150, I want to define as high. And if it's less than 150, like a 148, right? So then make it as normal, right? So the same thing, the lambda function I've used it. So if it is greater than 150, set it to high. And if it's less than 150, it's normal. So here, if you look at this, the target, after the target, you create one more column like a Tala string. That is what I'm going to define over here. Okay, df. So whatever the name you give, it will be displayed over here. So, right? So the same thing. And as I'm applying the lambda function and saying that the value of x, which value? When I say, so the Talash value, if it is 150, okay, then normal. It says x greater than 150, right? So 150 above will be all the highs. So again, this trying to read the header values like in header columns. Okay, how to define three categories like a Tala string field, like a low, high, very high. See, this is what I'm trying to hear. So instead of high, you just replace with very high. And if you think that okay, you want more, then you need to apply this thing. Go with this if then else. So since I got only two, like in high and low, I'm using this lambda function, right? Right? I'm using the lambda function. So here, when you want to have more, then to go with this thing of if then else, you need to apply the if then else statement, right? So if you want like an normal, high, and then uh, like an very high or very low, then you can apply. So that will help you to categorize them. So here, if I'm using only two, then you can try to get into this, uh, just apply the lambda function and then uh, store it back, right? So that's a easy task. So we try to make sure that use the correct method in a simpler method. We don't need to make it as too complex to the end user saying that okay, this is what I've used. So the advantage of this Python also, right? If you want to have more categories, then the same thing you have done, like a very minor, moderate, serious, and very serious, right? So the same case here for male, females also. If I show you, where did I show? I think it's in the bottom only. Yeah, it's in the bottom only. Category. See here also for male, females also, I just use the lambda function. So rather than going ahead with the if then else, so just for the chest pain, I've used the if then else. So easy and simple. So let's get into the section. So whatever we have. Okay, so we are here. So what you have done is I've added a new column and I categorized the Talash values and also displayed it. So df.header. So this will help to convert them and create a column. So we got the values in it, right? So the what is the next step in our problem statement? So last two steps are like, what percentage of females suffering from the heart disease are female? Okay. Okay. Yes. It's because it is a single statement. We went to lambda, right? Yeah, that is right. That is right. So and also you can utilize your own skill set, like, and if you want to apply if then else, you can apply if then else, or you can go with the case, you can go with the case statement. So it's up to you. So there are multiple ways to achieve it. Yeah. So that's the thing. And what percentage of people suffering from heart disease are females? And here also the next step is what percent of females suffering from heart disease are males? And also rounding the values to 3 decimal places. So the same thing, I'm going to show it up here. So when you say the percentage, I'm just trying to put the percentage symbol at the end, and 3 decimal places. So to get the 3 decimal places, I'm using 3. And so simple thing is I'm using the target column and also gender column. So I want to know the percentage of people suffering. So I know that there is a column called male and female, the gender column. That is true. So if I want to know how many males are suffering, then try to find out first of all the gender column. Okay, let's see, for females, gender equals to female. We need to define that. And also to identify the people suffering from heart disease, the target column will help us to find out how many people are suffering. So here, if I categorize, for example, with females, so here the females like zeros and all, right? So I can say it's 96 out of 303, right? If I just select this number of zeros, so I should be able to get the total number of candidates suffering, especially the females, like a 96 out of 303, right? So I just need to know the percentage, but at the same time, the target columns, right? So I just need to use the target column also and apply the logic. So what I'm trying to do is print percentage of the female suffering from the heart disease. So rounding it to 3 decimal places. And I'm also finding the length of these females and multiplying. Like it's more or less like in how much percentage you got in exam, the same thing, right? The same thing I'm going to do. So here the gender is treating as a female. And if I want to know about males, just convert them, gender equals to male, right? So that's what I'm trying to do. So next step, last but not the least, so also added this step. So for example, apart from this, I don't have anything, but just to help visualize in the uh, more graphical format, like, okay. So what I've done is I've just converted for the males and females and trying to show again the circular ones, like in female percentage people suffering from heart disease and the male percentage suffering from the heart disease. Okay, so this is not mandatory for this particular task which I've mentioned, but just trying to generalize and see that, okay, how well we can utilize these circular ones and then show it up, right? So this is one of the example. And also I've and also said to combine the above two pie charts as one. So for example, what I'm trying to do is here is I got the males and females, right? Uh, Sorry, I got the males and females, or also the chest pain one, right? The chest pain ones. So the chest pain ones and also the males and females, I'm mixing up both together and then trying to show it up. So with this, the problem statement and the solution has been provided. So here, the main thing which you need to learn out of this project is uh, what are the ways to import the data. That is a primary task. Whenever a customer says, okay, here is the Excel file, right? If he says that, okay, here is the Excel file, and I need the information, like in how many people are suffering from like in heart disease or not. So the very first thing is understand what are the different columns in it, right? What are the different various columns in it? Understand first, and try to see if there are any null values in it. That's the primary thing. So are you going to do the modeling part in this session? So modeling part in the sense, what you are in, may I know what you're interested in when you say the modeling part in the sense. So here, the task is uh, I was talking about like an source system. Like, so we have the Excel files, and you need to read the source files, right? Okay, applying the models to predict the heart disease. So apart from this, we haven't. So you just need to jump into the machine learning portion if you want to get into the deeper sections of predictions, right? So here with Python, we got some limitations. When you get into the machine learning portions, you can apply the logics and algorithms to get into the deepers of predictions, right? So what I would be doing is after a few weeks, I'll be starting with the machine learning thing. Then during that time, we'll be applying this Python logics and the machine learning logics, and we can take up the same example of the heart disease predictions, right? And then get into the deeper sections, right? Uh, so here the thing is that for the sake of the limitations, like in what we have learned is like in how soon would you be able to know machine learning? Okay, would that be okay? I'm going to say how soon would that be? For the machine learning of the project. Okay, so what I would say is, yeah, give me a timeline of 2 to 3 weeks. I'll be starting this machine learning thing. Then we'll the very first thing is I'll start picking up like an uh, very best algorithm that suits his heart disease prediction. Then I will apply all the logics, and then we will improvise this using the machine learning, right? So with the kind of limitations on Python, so we will be able to do certain projects only in Python, right? So here, what are the takeaway things, points out of this project is like an methods to read the files. Either it could be CSV or like in JSON. If it is like JSON, just need to make sure how to read the JSON file. And if it is a image file, here I'm talking about the image file also, right? So how to read the image file. So this is also been taught. And the next thing is the statistical functions, right? So like in how to apply the statistical functions on the given data set. That's one of the takeaway point. And also like in find the different data types present in the file. And also the key point for a data scientist is, if you're a data scientist, and the very first thing is when you get a data, make sure that the null values are there. If null values are there, how to treat the null values. That is mostly the cleaning portion, like in treating the null values. Otherwise, you get the abnormal results. So you may not be getting the correct results if you don't treat the null values properly. So if there are any null values, make sure that how to handle the null values. And if there are any certain portions, replace with certain values, and then you get a proper information. Otherwise, if there are, for example, there are 50 people who have passed the exam, and uh, just in case you've got zeros and all, if you, even though if you say count everything, uh, then what will happen if even the people who fail also, if you're considering, then you get the incorrect results. And if you think that okay, if you're treating the null values properly, you get the accurate results. Okay, these are all the accurate results, or these are all the people who have passed the exam. So that is the main criteria, treating the null values. We shouldn't ignore them in most of the projects which I've done. So treating the null values is the primary task, needs to be done. And identify the null values and replace the null values with certain values. So as I said, if there are anything to be replaced, try to ask the customer like, and what should be replaced. Like if there is a requirement like zeros and ones or something, apply the logic. And if something like here, for example, like a chest pain, uh, people may think that okay, zero means a null value, but here in this case, CP column, zero means very minor. So replace with the proper values. That's a task. So identifying what column it represents and how you're going to convert the data in the meaningful format. That is one of these takeaway point. And also how to visualize the data. How to visualize the data. So this is the key portion, right? Once you understand these things, like into visualization, we applied this matplotlibs on it. right? So especially over here. So that's the reason we have utilized the data frames. We have utilized the pandas, and we have also utilized these numpys also. But we haven't applied lot many things. Especially we have utilized the pandas and the seaborn a lot in this particular project, right? And also the OpenCV, just to show the image files, right? So apart from this, we try to utilize these for loops, whatever you have learned, and also we have utilized these case statements, right? Especially we utilize the lambda function over here, right? And also the if then else, right? You can use the case statements also, but I've used the if then else statements. So almost whatever been taught in the previous sessions. So each and every part has been it's like every portion of the Python skill set has been utilized over here, right? So this comes to the end of the session. But just in case if you guys have got any questions, you can raise it and send it across. We'll still try to clarify much, right? Just in case if I want to rerun everything, like can run all. So it will be the same thing. It just running the code, right? So let's see. We won't get any error message, nothing. But just in case if there is an error, I'll fix it. Yeah, there's no error, nothing like that. Right? Yeah, yeah. Everything has been run successfully. Yeah, this is what the project solution is. If you guys have got the solution and everything, you can still share to us, and we'll verify it. So, yeah, uh, thank you, Leja, for joining. I think it might be late for you in New Zealand, and thank you, Shravya and Ayan. Thank you very much. And yeah, so let me pause the recording.